I wanted to go over this effect I saw on someone's post on Reddit. I don't know if they posted the original, so I don't know where the original is from, but I recreated, or I tried to recreate my version of what the effect looks like. I did a couple different versions, so you can see kind of basically one is just filling up the shape, and one is filling it up and then continuing to go farther on with without being limited by the shape. So I think it's a cool effect, and I wanted to try to recreate it, and I thought it'd make a fun tutorial. So let's hop into Houdini and get started. The first thing we'll need is a tube to kind of create the basis for our effect. So we'll something about like that should probably be fine. And then we'll want end caps, but then and then we'll angle this a little bit, maybe 45 degrees. And then what we'll need to do is get rid of one of these end caps. So let's just go into the blast node, select one of the end caps, and delete it. So now we have a tube with only one opening. And then what we will do is poly extrude that so that we'll have a nice shell to work with, and something like that should be fine. When you work with the poly extrude and you want to have a solid shell, just make sure you tick output back. I think it's easy to overlook, and it will cause problems if you're hoping to create a solid shell with the poly extrude if you don't do that. So you can see we have that now. Next, let's use a copy and transform to just have a couple versions of our same cylinder, just offset. And then what we will need to do next is create something that we can use to have the kind of particles swirl in a vortex, along this length of this tube. So the way that I decided to do that is using a line, and I'll just kind of show you my my strategy. So let's template this, and then we want to have everything be linked between the line and the tube. So let's copy this parameter into the line's length, and then our origin can be the it will be the negative of this length divided by 2. That will keep the line in exactly the same position as the tube. So now if we adjust the height of the tube, our line is following along, and that's what we need for this setup. And the next thing that we will do is have a transform of this line as well, and we'll also copy create a reference copy of that one. So that same thing, whenever we change this one will be changed as well. But we have an intermediary transform that I created just so that I can adjust the length of the line to go beyond the end of the tube if I want to. So what we're going to do so if we try to change the scale here, it's going to go in both directions, and we only want it to go out the top where we've blasted away our at the end of our tube. So what we're going to do is we're going to, in the pivot translate, use an expression $y min, and that's going to set the start of the translate to the minimum y position, following our transform of the origin in this first node. So now we can modify the scale in the y-axis, and it's only going to go out the top, that's what we need for this example. So let's see how these things look together. So yeah, this is kind of where we're at right now. So we have our tube, and we have a line extending from the base of this tube and out through the end. Same thing, we can create a reference copy with the copy and transform if we want to. I think we're going to do a couple more steps before that though. So the next thing we will use is a sweep. And the sweep is giving us an error because it's saying, well, you haven't told me how to sweep the curve that you've given me. So you can use round tube. So that generates a round circular shape around the curve that you've inputted, and uses the number of columns and the radius to determine how that's going to look. So for us, we can use the instead of the surface type as quadrilateral, we can do columns, so then we can just get the lines around it, and we'll probably only, I think I used 4, so we're going to use 4 columns. So now we have 4 lines, and we are also going to apply rotation along the curve. So let's try something like 2 full twists. And so it should be working, and it actually is, but the reason we can't see anything is because our line only has 2 points on it. So if we increase this, we can start to see that, we can actually visualize the turns along the curve. And so that looks good, so that's ultimately the base of our shape for our the inside of our effect. So then we can copy that to or actually, I think again we're going to do maybe a couple more steps before that. So next, what we want to do is use a carve. So the carve will cut off a section of the curve for you. So as you can see, this one's going from the start to the end, where we need to use the second U so that we can go from the beginning to the end of the curve. And I think we'll just need to use extract so that we just have the points. We don't want to have the curve. We just want the points that are located at those locations along the curve. So you can probably kind of start to see how this is going to end up working. And in this example, I just animated this value along, and have that be linear, and then we can see I don't know why the playback is so choppy, but you can see the points turning and animating along the curve that we've created. So and yeah, again, like, you know, with Houdini, the great thing is that we can go back and we can change the number of twists or the length of the line, and any changes we make to our tube are automatically going to be applied to our line. So this is a really flexible way to set something like this up. And yeah, I mean, and this is just my method. I thought it would be easiest just to have, you know, a kind of following curve type setup rather than trying to do something all in a simulation. You know, that's just, you know, what works, what my first thought was, and what I think will work best for my situation. Okay, so we have our tubes and we have our animating points, which is the basis of what we need, and then we'll move into the simulation of things. So these points are going to be our Pyro sources. So that's not what I wanted. So we're going to copy some spheres to these points. And we don't want them to be that big. Let's see. How big should they be? Probably a little bit, maybe smaller even. Something like that for now is fine. And then we'll send those into a Pyro source node, which will scatter points across the surface of the geometry, and we will select initialize smoke because that's what we need. And we can decrease this particle separation if So it's just because it's just copying it to the points of the geometry. Okay. So we have our Pyro source creating density and temperature attributes for us. And then the next thing we'll do is create a volume rasterize attributes, which we have to select which attributes that it will convert from point attributes to attributes that can be read as volumes. So we want our density and we also want our temperature. So let's select those. So now we should see that, yeah, we now have visible volumes in there, but they're really chunky. So we want to decrease the voxel size to something that is more representative of our geometry. And it's still pretty huge, so we can also reduce the particle scale to better match our geometry. Okay. So that should be fine for now. And then, so I tried to initially set this up on the SOP level because I thought it would be kind of an easier way to see how these things are working if you haven't had much experience with dynamics. But I'm going to make use of a collider in this simulation, and I don't think the tools on the SOP level or on the SOP level are as flexible as they are on the DOP level. So I'm going to use a DOP network for the Pyro sim. So we'll do that, and you'll see kind of how to set that up. So we're going to need our Pyro solver, a smoke object, and a volume source. These are the ingredients. So if you're not familiar with using a quad view in Houdini. I think especially when you're working in DOPS, it's really useful. So basically it just means splitting up your viewport into four sections, and these two are linked and these two are linked. So, we can set the linking here, linking pane tab, this number 1 and this number 1 correspond to each other. So anything that like I do in here is going to be reflected above, and likewise for the section on the right. So I'm going to go to the object tab, and we'll hop into our DOP network on one, and then stay in the SOP level in this one. So for this, we're going to append a null and call it something like Pyro source, and then add that into our volume source for the SOP path. And then you can see nothing happens, even though it says it's set to initialize smoke, source smoke. You have to switch it to something and then switch it back so that it creates the proper fields. And we haven't created a velocity field yet, so we will come back to that. And for our, let's link our division size of our smoke object with our voxel size of the volume rasterized attributes. Something like that. Yeah. And so we can see that the bounds of our smoke object are not extending to the start of our simulation. So that is that's an issue for us, because we need the whole scene to be available, for simulation, not just like these bounds. So one thing that we can do is use a gas resize fluid dynamic node, and I was having an issue with the bounds not picking up the initial positions of the particles. So I just used a match size to send both the tube and the line to the Y minimum. So it just shifted them up to here and closer to the origin. So I think that's just an easier way to start your simulation, rather than trying to change the size of the initial bounds to capture those. So back in our DOPNet, this is kind of where we're at. So it's, you can see our points are emitting smoke, and it's trailing behind them, but we need to, and we're kind of getting this swirling vortex look, which we're looking for. We need to make a couple changes though to the way things are looking and moving. Let's bump that up so we can work a little faster. In our Pyro solver itself, let's go into the shape, and we want to turn off dissipation because we want the density to stick around forever once it's been created. And then where is this? Yes, buoyancy. We don't really need any buoyancy in this situation, and we can try to add a little viscosity to make the smoke a little thicker. And then turbulence, we will add in some turbulence as well, and then we'll see kind of where that gets us. Okay, so yeah, that's starting to look more like what we want, but there's kind of a problem, right? Is it just looks like smoke following these points rather than being confined into the geometry like we saw in the example, like this. Right. So obviously I I allowed it to escape at the end, but in that one it doesn't, and so that's kind of what we're going for. So there are a couple ways that you could approach this. You could create this. You could let this simulation run, and then after the fact, Boolean convert this to a VDB, and then Boolean it with a piece of geometry, which I think works okay. But what ended up working better is using a collider in the simulation, and then having that run, and then you can also do the Boolean on top of that as well. So I'll show you what I'm talking about. So let's bring in a static object and merge that in. And what we will need is our tubes from earlier. So these are going to be our collision objects. And so what we're going to do with those is create a collision source. So there's a great little node that allows you to easily just create a collision source. Basically what it does is it outputs VDB from the polygons from one side and to the geometry in the other. So what we can do is append a null, call this collide geo, and create another null and call this collide VDB. And if we highlight this one, we'll see this really chunky VDB. So we need to go into the volume tab and decrease the voxel size to something more reasonable. Like this should be fine. And then when we go back into our DOPNet, in our static object, we're going to throw the collider geo into the SOP path so we can see what's going on. And then in the collisions, we'll go to volume collision detection, use volume collisions instead of the default, and then we'll change the mode to volume sample by size. And then in our proxy volume, that's where you're going to drag in your collider VDB. And then if we turn off the display geometry, that'll hide the whatever you put in the SOP path up here, and then we'll see the collision guide so we can see what's actually being utilized by the solver to collide with. So this is what that looks like. And that should be fine for our simulation. So let's see what that gives us when we try to run that. Using a collider might make your simulation a little bit slower, but it shouldn't impact the performance very much. And so you can see we're really starting to get more of the effect that we're looking for, right? It's staying in those shapes and kind of progressing through, and somewhere at the end it should extend beyond the end of the tube and be able to kind of freely move around, where you can kind of see that happening now. Okay, and we also, I am running out of preview RAM, so I need to increase the cache memory. Something like 25 gigs should be fine. And then another issue that we have is it doesn't seem like we have enough density. So one thing we can do is we can increase that in the source scale of the volume source and see if that fixes it. So this will just give us a lot more density from our sources, and that should help to fill out the cylinder that we're colliding with. Yeah. So I think it's it's looking like things are going pretty well. But then what we will need to do to visualize things is use a dop import fields node and bring in our density field to see what the heck is going on. And then we will need our, I believe, our smoke object node. Or maybe we don't need the dop node. Let me just import a smoke object, and the field is density. Okay, yeah. So you don't even need to identify the dop node unless you have unless you have a specific one that you're wanting to choose from. But and there's a preset too for smoke where you can import all these fields, but we don't need these all for visualizing things right now. So we have our density field, and you can see it's brought it in as a volume. For us to work with it, with the VDB tools, we'll need to do a VDB convert and convert it from a volume to a VDB. And then we can use a convert fog to SDF if we want to convert it to an SDF. I think on the Pyro solver itself, there is I thought there was a way to export it as a VDB, but maybe that's only on the SOP level Pyro solver. Well, it doesn't matter very much because you can just do it here. So one thing that is difficult about this was when you bring it in, it looks terrible because it's so low res. So one thing we might want to do is use a VDB resample node. And then what we're going to do is have another VDB that tells it what resolution to be, right? So let's say 0.02, and you can see obviously it's getting much better in terms of the resolution, and so yeah, we're starting to get somewhere for sure. And with the VDB, we can use all the standard tools that we always can with VDBs, like smoothing and whatever else you want to use, and then ultimately converting it back to polygons, so that we can shade it and stuff. So yeah, that's gonna work just fine. And then we will here, let's let this run for a little bit longer. So one thing we will need to fix is our cylinder is not fully filling up the area. Okay, I was trying to remember, what exactly I had done to really try to fill those out as well. And so I think one thing that's really helpful is increasing the substeps in the solver. So that helps to smoothly emit the smoke into the simulation and allows for just greater density to accumulate, I believe. So that seems to be really helpful. And let's see if we turn on viscosity again, what happens then. So yeah, I don't think viscosity is going to be helpful for us in this case. So we're just gonna go with the settings we have now. So we just have a little bit of turbulence. We turned off the dissipation. We turned off the buoyancy, and we added more substeps. And so that should kind of give us the starting point for what we need out of the simulation. And for making this look nicer, we can increase the or decrease the division size, increase the resolution of the simulation, and we could also potentially play around with the density values that are being sourced in. We could add, more customized velocity forces and, things like that. But for now, for what we're doing, I think this is going to work fine. And we will let it run for a bit, and then we'll go back out to our VDB operations. So, this looks pretty filled out on here, but we can take it another step in terms of cleaning up the outside by basically just using our cylinders to cut out a little bit more of the outside of it. So what we can do is, what we probably want to do is just have a different stream for the geometry that's going to be used as a Boolean, and then we will convert it to a VDB. And then we are going to use a VDB SDF subtract is what we're going to be using. And you want to make sure you use it before your convert so that you're working with both SDFs. And yeah, you can see how we've got a cleaner edge to the outside of our geometry. And then we can go up and adjust the distance to increase the range where it's Booleaning, where it's cutting away from the this mesh itself, or not mesh, this volume. And we can even, because I think one thing that's happening is we might need to actually modify the inner radius of the tube. So what we can just do is create an entirely new stream for our Boolean. So here, and then we can go even all the way up to the base of our tube and, dial that radius in to wherever, is going to look good for what we're after. So something like that's probably fine. And so you can see we have a pretty clean edge on the outside and our simulation working on the inside. And then once it's been converted to a VDB, once it's been converted from a VDB to a mesh, then you can, go ahead and shade everything. And you could, one thing that might be helpful is to create some kind of float attribute that runs along the length of these. I don't know, you could use it for shading, or you could use it for masking, and with the with the attribute adjust float, you can use one of the ones I really like is the linear pattern type, and you basically just set up a line. You set up the points of the line wherever you want them to go, and it will create a float value between those sections. So we have this just called attribute, and let's visualize that. And so yeah, we can create an attribute running along the length of the tubes, and use that for whatever we want to, which could be helpful. So we could use our leading points as a mask to just have a masked leading edge, and we could do whatever we want with that. Bring it into a attribute VOP, and use that to, maybe we want to shrink those in a little bit, or maybe we want to we can add some noise to the leading edge using that mask attribute, or that doesn't work. Yeah, we can remap it to have noise only on the lower part. So yeah, we could use that for a bunch of purposes, basically. So yeah, after the fact, after our simulation's created, we can also still, do some fun things. And also, I think it's always good to think about how, you could use something like you've created earlier to influence something later on, which is always fun. And then let's set up our camera real quick, just so we can get a quick visualization of, what this could look like. All right. So we'll need a dome light. Just use whatever dome lights you like. And let's turn off enabled in viewport, and then add a material network so we can throw a material on here. Add that in there. It's going to be metal. And then let's hop into the render view real quick, see what we have. So yeah, that's what we've got so far. Always a good idea to save your projects. And we can turn this off of the background so we don't have the dome light visible in the background. And then let's set up our depth of field on our camera. I want to have a shallow depth of field. And we'll add a either a bump or roughness map to this to add some breakup to the surface. I like this Poxo one for this. I don't think we will need. I don't think we'll need to do anything with the UVs or arrest attribute because this is just going to be moving along, and the noise will just be in place because, you know, once it's formed, the noise is going to be in place. So we'll just not worry about that for this example. And so we're using a black and white noise. So our bump map needs to be set to height field, and we'll pump that into the bump input, and the scale is still too high. So let's, okay. Something like that, starting to look okay. We have that running along there, and we can bring in our mask attribute, which should be on there. Yeah. So our mask attribute's on there, and we can put that in a ramp if we want to remap it. You know, using the ramp, or you can also add noise in here. I mean, it's not very flexible, but you know, it's something you can mess around with. Could change the radius so we can get a more or less space on it. Let's have it be pretty tight on it for now. And then we could use this to, what could we do? We could scale our bump map by that using a multiply. So that again, we just have noise on the front end, if that's kind of what we want. And then like, you know, like, I don't know, like this is coming on as like more, you know, this part's, you know, growing and it's noisy, and then it gets cleaned up as it moves along. I think, you know, could be cool. And yeah, I think, you know, yeah, I mean, I didn't go super extensive with the look development on this example. So this is, you know, about as far as I had taken it. And then, you know, you can add post effects as well if you want, you know, to have some nice highlights on here, or to throw a lot on this. get some cool cinematic looking renders out of Houdini with Redshift. And yeah, I mean, I think that's most of what I had wanted to cover with this tutorial. I think it's a super fun effect, and it was really fun to figure out how to, at least one strategy for trying to recreate this. I'm sure there's a million ways that, you could do this, but this one ended up being a pretty cool result for me. And, I think, if you refine it even farther, it could be super cool. So yeah, I hope you enjoyed this one, and I will, let me know if you create anything with it. I'd love to see anything anyone makes. And, I can put the project file on my Patreon too, if anyone's interested. But yeah, I will catch you in the next one. Peace.